Hi everyone, my name is Pierrick and I work as a Developer Relations Engineer for the Google Ads API. Welcome to the Optimization Score and Recommendation series. In this episode, I introduce some best practices, which are discussed in more detail in other episodes. This can help you get started if you're new to recommendations, but it can also be helpful if you want to optimize your existing integration. For a complete list of resources and for links to other episodes, please check the video description. Alright, before deep diving, let's start with a quick reminder of what optimization score and recommendations are. Basically, their objective is to help you optimize the performance of existing campaigns. Integrating those in your application can help to take automatic actions, have users keep their focus on strategic activities, and integrate additional signals and features to achieve greater performance. There are multiple levels of integration that are possible. For the least to the most advanced, you can redirect users to the Google Ads UI so they can manage recommendations from there, retrieve optimization scores, retrieve recommendations, support automatic actions on recommendations, and support manual actions on recommendations. It's usually recommended to integrate features incrementally to avoid unnecessary development cost and to drive adoption. Regardless of the type of integration you end up choosing, make sure to comply with the Enforce Required Minimal Functionality, or RMF. RMF regroups all the features and other functionality that developers must offer when using the API depending on their use cases. You may also want to upgrade to the latest version of the API to take advantage of all the features. Now, let's focus on the optimization score. It tells how well things are set to perform in real time at account and campaign levels. This score is subjective, but it's a useful indicator of account health, and it's particularly useful to prioritize account management operations. It's based on recommendations that are currently eligible and takes into account historical data such as pending. It can also complement any other indicators you may already have. While working with optimization scores, you need to keep in mind that they are not always available because some entities simply cannot be scored due to a lack of historical data. They are updated when actions are taken on recommendations, but they may also change even if you did not take any specific actions. This is because they are continuously evaluated against lots of variables. We highly discourage relying on any assumptions on how things work behind the scenes. Even the evaluation method is continuously refined. We recommend retrieving them in real time instead. One exception is when you need to find the score of a manager account or any other arbitrary group of customers. Computing the weighted average of all the customers can lead to a number of requests that is so large that it's impossible to evaluate in real time. In that particular case, you should consider using periodic evaluation or cache instead. Alright, let's change our focus to recommendations. They are used to edit campaigns and optimize their performance. We highly discourage relying on any assumptions on how they are evaluated because of the same reason as with optimization scores. The evaluation methods are continuously refined. The best practice is to retrieve them in real time as well. Accounts usually have lots of recommendations, so it's often better to filter, organize, and order them before taking any actual actions. For example, you may want to highlight the recommendations that will have the most impact on clicks or that are more likely to be applied by users. You can rely on the uplift or impact metrics for that. The uplift represents how much the optimization score will increase if you take an action on the recommendation. But it's important to note that uplifts are only estimations and that the combined effect of recommendations may not be a strict sum of each individual uplift in isolation. Or put in different words, summing all uplift of a campaign or a customer with its current optimization score does not always equal the perfect score, so you should not rely on this assumption. The impact metrics, on the other hand, include both the baseline and the potential. You will need to pull the data on the client side before evaluating and comparing the relative impact between recommendations. For most applications, It's wise to design solutions that are generic to all recommendation types because they continuously evolve. This is to easily adapt and to benefit from the latest improvements. Depending on the application, it may also be useful to enable recommendation types that are not fully supported by the API, but are supported in the UI. In that case, the best practice is to retrieve the Google Ads UI deep links associated with the recommendations from the API and redirect the end users there so that they can take manual actions. When the recommendations types are fully supported by the API, it's possible to take actions directly from the recommendation service. It can be done automatically or using input from users. It's easy to develop and maintain. It automatically updates the optimization scores and recommendations. It helps Google to improve the evaluation methods and ultimately the quality of future recommendations. And it covers most, if not all, use cases because recommendations can be applied with customized parameters. The recommendation service on its own is fairly straightforward. There are only a handful of things to keep in mind when using it. Recommendations can become ineligible at any time. This is why we recommend taking actions shortly after retrieving them to avoid failures. Dismissing recommendation doesn't lead to a penalty of any sort. In fact, it's quite the opposite because it helps to prioritize actions and to improve the quality of future recommendations. Depending on the recommendation types and features you want to support, you may have to customize parameters to apply recommendations. It's pretty simple if you remember 3 things. First, that not all parameters are required. Second, that most recommendations come with recommended parameter values that can be used. And third, that customizing parameters only brings significant value if additional signals are used to refine them. Changes made by applying recommendations are tracked like any others, but those made to the recommendations themselves are not. You should keep track of recommendation details if you want to retrieve their changes later on. The last point is related to bulk requests. They can be used for better scalability, but make sure to do it right by enabling the partial failure mode, by sending only one operation per recommendation, by sending a valid number of operations, the current maximum being 100, and by making sure that you can wait for the response to come back, which can sometimes take several seconds. Alright, this was a lot. I will finish by highlighting some important facts to keep in mind during development. You should define and keep track of the historical data you need early on. For example, you may need to keep track of the optimization score over time to display it to your users on the dashboard. You should avoid making assumptions. For example, always check the presence of field values before using them. You should avoid relying on a cache. Prefer retrieving data in real time and taking actions shortly after to reduce confusion and failure rate. You should be careful of quotas and limitations. It's especially true when retrieving data for large groups of accounts such as manager accounts. If you need to optimize, one great way is to use bulk requests whenever possible. You should use logs and test your code thoroughly. For examples, you can mock the Google Ads API, use real Google Ads accounts, and nurture a healthy pool of recommendations to test against. Last but not least, you should make things resilient. This can be done by enabling the partial failure mode, by handling unpreventable failures such as concurrency, validation, internal and network errors, and by automatically retrying requests whenever relevant. Alright, that's all I had on this. If you're interested in this type of integration, you can check other dedicated resources listed here and check out the other episodes of this series. Thank you for watching. I will see you in other videos.